Hey guys, Larry C here. You know, my math teacher told me when I was a student in high school, she told me that I was average. And I was like, that's so mean. Shout out to y'all. Enjoy the video.
Come on now, dog. Come on, man.
Hey guys, Larry C here. Welcome to another installment of Build a Stats course with me. And today we're starting a really important chapter, chapter 3 in the elementary statistics book by Mario Triola, 14th edition. Again, they don't pay me to say that, although that'd be really nice. And this is fair use. All right, so shout out to the coach gang. So it's in this chapter that we begin to, dive deeper into the data by doing some pretty important calculations. And the first of those calculations is finding what's called a measure of center, which, as you can see here in the guided note packet that I built, right there in the box, a measure of center is a value at the center or middle of a data set. Now, as I was waiting to pick up my daughter from dance last night, I had read through the section again, and there's a lot of information, just like in any section that we're going to encounter most likely. And of course, the goal is to really sift out the essence of the section without diluting the integrity of it. So one of the challenges with a section such as this, which is laden with some more terminology, which is probably not surprising, but one of the challenges in doing that is keeping the students engaged. Now, when I was a student in my master's program for math, the books kept on getting smaller, and so did the directions for the problems. In fact, the general format of a math textbook in graduate school is theorem proof, theorem proof, theorem proof. And it can get like that sometimes when you're, even teaching at the community college level and you're designing notes and you're like, okay, yeah, let me just put all the definitions in here and then we'll just kind of run with it. For somebody like me, and if I'm feeling this way, I'm sure a lot of other people are. For somebody like me, that's pretty boring, all right? And I'm not likely to remember a whole lot of information when it's presented to me that way. So I try my best to not do the theorem proof, death by theorem proof. How many times can I say that? All this to say that I wanted to really introduce these metrics that we're going to encounter with something that I wouldn't expect your status quo stats teacher to introduce it with. And so, as you can see on the screen here, this QR code, it's got a QR code to a fluoride conspiracy theory. So that's what eventually came to mind as I was thinking about the design of this section before picking up my daughter from dance. It's like, who doesn't like a good conspiracy theory, right? So whether that's people thinking that their phone's listening to them, or people that think that lettuce is fake, or traffic starters, or as Hecklefish from the YouTuber Wi-Fi, shout out to that guy, and Hecklefish, of course, the lizard people. All right, you should check out their channel. It's really cool. So, when I got home, I wanted to procure some data on a conspiracy theory, but of course, I wasn't sure what conspiracy theory I wanted to do. There's so many of them. So I enlisted the help of AI, and I'll show you what it suggested. I went to my go-to search engine, Claude, AI search engine, and let's see. I first asked it, and actually I should talk about this for a second. I asked it to create just like a template of, give me some design ideas for guided notes. And I said, could you give me a few guided note design ideas I could build on for section 3.1 of the book that I'm using? And I'd like to keep it to no longer than 3 to 4 pages and would like engaging examples as well as mini diagrams illustrating the important topics within the section. Thanks. So one thing that you learn about AI is that sometimes you got to get really specific about your prompt. And to be honest with you, I think that this is mid in terms of specificity, especially some that I've seen. But something interesting happened. It said Section 3.1 of Triola's elementary statistics covers basic concepts of probability. And unfortunately, that is not true. Section 3.1 or 3-1 is on measures of center. So I kind of wondered about that, and I said, oops, I meant section 3-1 titled measures of center. Now, I'm not sure if formatting it this way as opposed to 3.1 is what did the trick, or me specifying the name of the section, but it finally caught on and said that's actually in chapter 3 of the book, which, that was part of my original prompt. So you got to be careful when using AI. Always vet your information. And I'll get to that. I'll get to some more on that in a little bit. Okay, so it decided to, kind of chunk things into different parts. And as soon as I saw 9 parts, I was like, there's no way in hell that that's going to be able to fit in like 3 to 4 pages. So I decided to take a peek anyway. It created this document for me, which I'll show you. So right here, section 3.1 measures of center. And I think what it interpreted as engaging notes is using different colors, which, yeah, I mean, that's a level of engagement. But you got to remember, printing these off for students, and most institutions, especially mine, they're not going to be cool with you printing off colored copies when you have so many students. So all of this has got to be in black and white. So that kind of defeats the purpose of using colors in terms of creativity. I do like these boxes, though. I think that it got that right. And then it created a working set that we're supposed to use throughout this section. And I kind of did model my section notes on that. It's what I wanted to do anyway. But then it attempts to, give you some formulas, which, those are not the best in terms of, typesetting. Talked about the median, gives you some tips on odd number values, even number values. And I'm not trying to dog or shit on Claude AI. I'm just saying that, don't just put a prompt in and then just take whatever it gives you and use that. Okay, you got to be a little bit mindful about designing your notes. So it did fairly decent. Okay, I'd say it's mid, like the mid range. But I think it really didn't, refine it to something that could be taught within 1 hour of time. So I said, okay, well, let's kind of poke around with this some more. So I went back to Claude and I might have done a different chat. No, it's in the same thread. Okay. Okay, here it is. So eventually, I wanted to bring in the idea of a conspiracy theory, and I say, you're catching on to my style. I'm wondering if you could whip up an interesting data set involving a popular conspiracy theory of your choice that would fit this section of notes. Of course, it's always going to make you feel like a hero with its feedback. Love this idea, blah, blah, blah. Of course, it's going to do that. So it gave me some examples. The Roswell UFO incident, which I didn't really like that a whole lot. So I said, can you give me an alternative conspiracy theory that is a little more spicy? And so I wanted it to be more spicy so that it could be a little more engaging. Of course, it gave me some positive feedback. And then it offered 4 options. Option 1, the moon landing was faked. That's a very popular conspiracy theory. Option 2, the government puts fluoride in the water to control minds. That's a pretty famous one. The lizard people. Option 3, world leaders are secret reptilian shapeshifters. And option 4, which I almost went with this one to be honest with you, the Mandela effect, or CERN, the particle collider place, is rewriting history. So if you've looked into that, there's a little bit of information about the Berenstain Bears, I think, Fruit of the Loom, and Mirror Mirror on the Wall. The Mandela effect says that it actually says magic mirror on the wall. So really cool stuff, which as you can tell, I'm pretty engaged in it, and hopefully the students will be too. So I was kind of caught up between fluoride in the water and the Mandela effect, and it kept on suggesting the Mandela effect, but I kind of pushed back. I said, I see what you're saying, but I think fluoride, the fluoride one, is a little more tangible in terms of legitimacy of data. What you say with regard to the Mandela, or what say you with regard to the Mandela effect on this regard, reading with Mr. C. If you think there is as much science behind the data set for it, I just might go with it. And so here it kind of confessed, honestly, you're right to push back on that, and I'll give you a straight answer. Fluoride has genuine scientific infrastructure behind it, whereas the Mandela effect says is a much weaker foundation scientifically. The data would essentially be people self-reporting how many times they misremember things. And remember, self-reporting, okay, is kind of in the family of voluntary response, and is not always accurate. So that was kind of a red flag for me, which is what ultimately helped me decide to go with fluoride. So I dug into fluoride a little more, and it revised the notes it originally gave me, and within it, it provided me this table of data values and also this verbiage right here. A group of conspiracy theorists claiming the government uses fluoride in drinking water to control the population conducted their own water testing campaign. They collected tap water samples from 10 U.S. cities and published the following fluoride concentrations in milligrams per liter. For reference, the EPA's recommended level is 0.7 milligrams per liter, and the legal limit is 4.0 milligrams per liter. And I thought, wonderful. Okay, I love this data set. But then after a few minutes, I'm thinking, okay, well, would these actually be plausible values, or is Claude just making some shit up? And so this right here is valid, and you can roll with. And let's see, said, I asked eventually, are the fluoride data values valid? It's a great question to ask, and the honest answer is partially. It says the values in the range of 0.4 to 1.2 milligrams per liter are entirely plausible. It threw an outlier in there where it said it took creative liberty, and I'm fine with that. I constructed it to serve the lesson. It's believable as a miscalibrated home kit result, and it stays below the EPA legal limit of 4.0. So essentially, I trusted it at this point, and asked it to, maybe give me specific cities that could possibly have these levels of fluoride in their tap water. And so I think that was essentially it. There was one other thing that I asked it to help me do, which I'll get to that in just a moment. So to supplement this conspiracy theory, I have a video. This QR code takes you to a YouTube video, which you can scan with your phone and check that out. So I'm not supporting or dismissing the conspiracy theory. I'm just trying to keep it down to the math while hoping to keep students engaged. All right. So there's a lot of terminology that is part of this section, and I thought maybe a good thing to do as kind of like an anchor point would be to graph the data in terms of a dot plot, which this is a good review skill. All right, so we addressed dot plots a couple videos ago, so that would be a great review exercise for them. And so Claude created this grid for me, and I really thought it did an excellent job here. So the axes are labeled correctly. We've got good tick marks to use, both on the horizontal and vertical axes. And I like that it put the EPA recommended amount of fluoride per liter, 0.7, and then it put the upper threshold of fluoride milligrams per liter somewhere in this area, so 4.0. So I'm going to have the students create a dot plot of this, and I can show you what that kind of looks like plotted out. Hang tight with me. Okay, so if the students do the dot plot correctly, it should look something like this. So we have all the 9 of the 10 data points plotted as part of the dot plot, and then there's this point, which is the outlier. So that's going to bring up some great discussion. So going back to the notes, so I have a visual for them to always reference back to. And I kind of lead into the terminology with a question. If you had to decide on a middle or typical value concentration level based on the dot plot, what would you say to that? So great discussion point there, and I think that that's a good segue into some key terminology. The first term being the mean or arithmetic average. So I have the definition of that, and quickly followed up with an example where we'll do that together. And then over to the right, this is something that I normally do. It's kind of like sidebars, so mean notation. So it's not nice, okay? But anyway, I have the notations for the mean that the textbook uses, and I just used the insert equation feature, and then I went to the sigma for the large operator. Okay, so it's a sigma. Shout out to the Gen Alpha brain rot. And I did fraction, and then I just inserted the sigma as part of the numerator, and then the rest of this. And I left myself some space just to indicate that this is for a sample and this is for a population. So then the next term is going to be the median. The median of a set of data is the measure of the center that is in the middle value when the original data values are arranged in order of increasing or decreasing size. And then I took some advice from the textbook. It says, note that about half of the values in the data set should be less than the median and half should be greater than. So the key word here is the about. Okay, so when you calculate a median, you might have one more data point on the left side of it versus the right side of it, but it should be roughly in the middle. And there's 3 notations that the textbook uses for median, so I'm going to have us jot that down. And then here, what I wanted to include was how do you handle finding a median if there's an odd number of data values versus how do you calculate a median if there's an even amount of data values, which is something to clarify. And I speak from experience. I often struggled with finding the median when there is an even number of data points, okay? So make sure you emphasize that if you're going to be using this section of notes. So then find the median of the fluoride data set. And then I took some information from the textbook and condensed it down to a note. And so it allows me to make some remarks regarding the mean and median, and then it also allows me to squeeze in the term resistant. Okay, so the first couple of notes are about outliers. Outliers can greatly impact the value of the mean, or outliers have less of an impact on the median of a data set. The degree to which an outlier impacts a measure of center is known as resistance. Okay, and you also want to clarify that the mean uses all the data values from the data set, whereas the median doesn't necessarily use every data point. All good stuff that they need to know. And then, of course, the mode. All right, so it's the value or set of values that occurs with the greatest amount of frequency. And then there's some notes about that as well. The mode can be found with qualitative data, and it's the only type of measure of center that we can use for qualitative data, by the way. A data set can have no mode. And a data set can have multiple modes. So I have a little spot here for us to write down bimodal. And then I also have a spot here. Why is it slipping my mind here? Multimodal. And I should have remembered that because I thought about the multiverse when I was editing this. And last but not least, another measure of center is known as the midrange. So I have a formula box for that right underneath the definition for it. And a little sidebar here, the midrange is definitely not resistant to outliers. All right, and that's because of the formula for it. So we're going to finish the feature data set conspiracy theory, at least for now, with finding the midrange of the fluoride data set. And one of the last things that the section mentions in the textbook is finding a mean for frequency distribution. And then, oh, this is a typo. This is supposed to say weighted mean. And I'm going to lie and say that I waited to edit this until cutting this video. Okay, so further down the rabbit hole, I thought I'd come up with a creative title to phase us into this last portion of the notes. So here I'm introducing the idea that you can find the mean of a frequency distribution as well as calculate something known as a weighted mean. They're kind of related to each other. And we're going to jot down the formulas ourselves into these boxes. And I left myself some room on both sides of these boxes so that we can annotate it. Because the formulas look similar, but they're not exactly the same. And the difference between the two formulas is important. So there's that. So we're going to do an example where we compute the mean of the data that's in this frequency distribution. And I took this from the textbook, so it's a screenshot. And one of the things to emphasize with this is that if you're computing the mean of a frequency distribution, then you have to use the midpoint of each class, multiply each midpoint by a corresponding frequency, add that all up, and then divide by the sample size, which is going to be the sum of the frequencies. And what's interesting is that when you do it this way, you might not get the exact mean that you normally would if all these data points were just listed out and not categorized into classes. So that's why I have this note here. Okay, since we're using class midpoints when finding the frequency distributions mean, the value we obtain could slightly differ from the mean that can be calculated using an original list of data values that corresponds to it. That's kind of wordy, so I'll think about that, maybe find a way to trim it down a little bit. And then one of the last examples, of course, is going to be one that corresponds to a weighted average. And one of the most popular areas of life where a weighted average really matters is GPA, so grade point averages. And I thought this might be a good avenue for which to put in a cheap plug for a prize that I'm in charge of at my institution known as the Pythagorean Prize. Here's a little anime picture of Pythagoras that I've had designed. And it says here the following data is taken from a Pythagorean Prize application for the 2024 to 2025 Pythagorean Prize competition. Compute the GPA, rounding to 2 decimal places if necessary. So these are actual values from an application that a student submitted during that year. And it allows for good discussion about how to calculate an official GPA. So, you know, sometimes what students will do is they'll just compute an arithmetic mean where they just add up the grade point averages and then just divide by the total number of grades that there are, which is not the correct way to compute GPA. So, you know, I left ourselves some space here to do that with. And then in case any of the students are interested in applying for the prize one day, I included a little blurb from our Pythagorean Prize application. And your boy, Mr. C, here, like I said, is in charge of running that yearly prize. So I wanted to finish this section off with them getting a little bit of practice. And I thought to maybe put like an even deeper conspiracy tone to it. And what I realized is that in doing it this way, where I have a data point shaved off, this also allows us to see, um, you know, the impact of an outlier from, a different set of measures of center values. In other words, what's the impact on those measures of center when you include the outlier versus when you exclude the outlier? And this is something that scientists do in real life. And one of the reasons why they do that, which is shady, is to, lie with statistics. So it's a great discussion point as well. And I'm not trying to toot my own horn here. I'm just trying to convey that, you can add a lot of context and depth and more dimensions to examples by connecting it to real life stuff. Okay. So I'm calling this example "You Try" and scenario 2.0. Let's imagine that the person who was designated to collect the water sample for City J suddenly went missing under mysterious circumstances, yielding a slightly altered data set than that of page 1. And you can see that I cropped out City J, and I'm going to have them use this new table to find the mean, median, mode, and mid-range, followed up with kind of like a contextual question, open-ended, in words. How does the removal of City J's water sample impact the measures of center from before? How could removing or even including an outlier such as this be used as an advantage in the real world? So that is how I'm closing up the loop with this whole idea of conspiracy theory. And hopefully it's an entertaining concept. And if you want to use something like this and have questions about it, feel free to let me know. And I'll be happy to send you a copy of the notes if you want, as well as all of my sources. But, I can neither confirm nor deny certain things about this section of notes. Just kidding. But I can confirm that this is where the video is ending. Make sure to hit the like button, subscribe, ring the bell for notifications and all that jazz. Shout out to you guys, the Stat Cats, the Coach Gang, and all of the wonderful people of this Earth and YouTube community. So take care, guys. Let's keep bossing up. See you in the next one.